to this. So it's included and we have not included. Right? Included and not included. And what this means, well, we know that, right? We know that included means that it is a bracket, right? There is a dark circle, and we use less than or equal to or greater than or equal to. Not included means that there is parentheses, open circle, less than, or greater than. Now, let's look at some examples. Right over here. Example 1. Right? Example 1 tells us to find, right, -1 to 1. So our x value is going to kind of exist between these bounds. So we draw our little number line, right? This is going to be 0, this is going to be 1, this is going to be 2, this is going to be 3, this is going to be -1, this is going to be -2, and that's going to be -3, right? And so our whole goal here is to try to see where will my line exist. So where's the color? Oops. No color, I guess. Oh, down here. So let's just look at our color. So that means that our x has to be around -1 and 1. So we use an open circle on this side, right? Because it's not including. And then we draw an arrow between these two, right? How it would look like in set builder notation, it would be -1 and 1, right? My x is in the middle. And well, since it's using brackets, I mean parentheses, we have to use less than. So that's how we know. That's how we know that we got to use less than signs because there are brackets. However, let's look at example 2, where we have something like brackets -4, and let's say 2, close brackets. That means if we were to draw our line like this, what do we get? Well, we have 0, we have 1, we have 2, we have 3, we have 4, and we have -1, -2, -3, -4, right? And so what does that tell us? Well, it tells us that our number has to exist between -4 and 2, right? But since it's brackets, we can include. Our x can be -4, and that's why we use a dark circle, right? A dark circle, and it's all the numbers in between, right? Set builder notation will kind of give us the idea that it will be this. Between -4 and it's between 2. Our x is between that, and well, since it's included because it's a bracket, we use less than or equal to, less than or equal to. We know that because of this, because it's a bracket. So far, so good. Let's look at another example. Let's look at example 3. All right, example 3 is kind of like this, -5, comma, infinity. Remember that infinity and positive or negative infinity is always going to have a parentheses because they're not included. You can't capture infinity. There's no way you could say, hey, this is infinity, and that's a specific number because infinity keeps growing and growing and growing and growing. So we draw our number line again, right? This is my 0, -2, -3, -4, -5, -6, 1, 2, 3, 4, 5, right? Well, 5. We look at 5. Is -5 included? Yes, it is. Why? Because of this bracket right here. So it is included, so we're going to draw a dark circle, right? Like I said, can we include infinity? No, we cannot. So our arrow kind of goes on forever, and we draw a line like that. Why? Because x can be full -4, it could be -3, it could be -2, it could be -1, it could be 0, it could be 1, it could be 2, it could be 3, it could be 4, it could be 5, and it could go on forever and ever to positive infinity. It could be all these numbers, and it could even be -5, but what it cannot be is -6. It cannot be. So that's a no. So that's why our arrow goes that way. And essentially that's pretty much what we kind of view it as, right? If we were to draw this as a interval notation, right? What we would do is, well, our number or our value x, right, has to exist between what? Well, it has to exist between positive infinity and it has to exist between -5, right? But notice how -5 has a bracket and infinity has a parentheses. Well, that's why we have a less than here, but here we have a less than or equal to, and that's the big distinction. All right, this part is for that, and that is for this. And that's how we kind of conclude or state. This is going to be very important when we write domain, right? But there's a key difference. So let me just say something. So for domain, right? Remember, domain deals with x, right? It's all your x values, whereas range deals with all your y values, right? So if we're talking about our domain, right, we would have a number, right? Like a is in between, x is in between b. Whereas for domain, right? And this could be either less than or equal to or greater than or equal to. It depends on the situation. Whereas range is a between y or between b. So be very careful. Range and domain depend on our x values and our y values. And then, of course, it depends if it's included or not included. But be careful with range and domain. You don't want to put or switch these around. Let's now move on to the next part, right, of our equation. Oh, graphing. So there's going to be a lot of this on the exam where they kind of tell you, hey, given the equation y is equal to x squared plus 1, right? Select integers between -3 and 3 and graph. Right? All this is really saying is, hey, get the numbers between -3 and 3 as your x values and give me points so you could graph. So in this part, we get x, and we have f of x. This is also known as y, right? So they're kind of interchangeable. And we're going to do this. We're going to get -3. We're going to get -2, right? -1, 0, 1, 2, and 3. And so all we really have to do is just plug in -3 into that value. So let's do that. So first up would be -3 to the power of 2 plus 1. Right. And what is that? Well, -3 to the power of 2 is 9 plus 1 is 10. Perfect. Now what's next? Now what's next? Let's try our next number. -2. -2 to the power of 2 is 4 plus 1 is 5. Perfect. Let's try our next number. -1. -1 to the power of 2 is 1. 1 plus 1 is 2. 2. Our next number would be 0. 0 to the power of 2 is 0 plus 1 is just 1. And if you remember from your not college, but when you remember from your Algebra 1 course, right? This is a parabola, so you're kind of see a mirror image. 1 plus 1 is 2, right? 1 to the power of 2 is 1. 1 plus 1 is 2. Perfect. Now let's do 2. 2 to the power of 2 is 4. 4 plus 1 is 5. And last but not least, since they only want numbers between -3 and 3, it's 3. 3 to the power of 2 is 9. 9 plus 1 is 10 as well. So those are our points. Right? These are our points. And I guess in a way, if you have to graph something and you don't know where exactly they have to be at, always create a table. And that table will kind of help you decide or predict where our points are. And then you could just graph them. So this is saying, right, we have points. We have points -3, 10. We have -2, 5. We have -1, 2. And then we have 0, 1, 1, 2, and 3, 10. And these are our points. with these points, you could graph whichever graph you'd like, right? We transport them on a grid. Not sure if this has a grid. Let me see. Does not. But that's the case. So let me just erase this real quick, and then we could kind of deal with our grid. So now we have our points, right? Let's kind of draw a graph over here. One, two, three, four, five, six. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 1, 2, 3, 4, 5, 6, 7, 8. And then we don't have any negatives, so I'm not going to really deal with the negatives, but if we were. All right, so let's draw our first point. So our first point is negative 3, 10. All right, negative 3, 10. Let's do it in this weird green. So negative 3 is going to go 1, 2, 3, and then up 10. 1, 2, 3, 4, 5, 6, 7. So it's going to kind of be right over around here. All right, what's our next one? Negative 2, 5. So 1, 2, 3, 4, 5. Right over here. Next, negative 1, 2, 0, 1, which is right here. And then on the other side, we have 1, comma 2, 2, comma 5, and 3, comma 10 all over. Sorry, there's like a little speck on the tablet. All right, and then we draw our little graph. Right, and we kind of say it's increasing. Right, if we were to ask for the domain of this, right, domain is the x value, so you kind of look how wide or how skinny my graph is. Notice how these will go on forever, so my domain is all of x. So it's between negative infinity, comma, infinity for my domain. All right, and then in set builder notation, there'd be x is in between infinity and negative infinity. All right, my range, however, right, range up here. My range is my y, so it has to be between has to be between two things. And notice how for range you kind of want to look at your y-axis, right? And your y-axis here, notice how it starts at positive 1 and then it keeps growing to infinity. So that would mean that my range is between 1 and it could be 1, so it's less than or equal to infinity because it grows. Okay, and then to the notation, it would be bracket 1, comma, infinity, close parentheses. Because notice this is my y, and my x would be, let's say, in this purple. My x would kind of be on these lines. But notice how it keeps growing and growing and growing. So that means they go on forever. So we can't really say that's my x because they keep growing and growing and growing and growing. Eventually, my graph keeps going, so then my x value will be over here, and then it'll keep growing, and it'll keep growing, and so that's why we say my domain is from negative infinity to positive infinity, and my range is from positive 1 to infinity, because on my graph, it's from positive 1 to infinity. All right, let me just erase this real quick. And so when we're given things like that, that's how we would graph it, right? If they give you specific intervals, then in between those intervals, you should graph. All right, so let's go again with another question. Let's look at like some absolute value. So absolute value is just the distance between that number and 0. So example, the absolute value of 5, right, is just 5. Whereas the absolute value of negative 3 is just 3. Because how many units away is negative 3 from 0? 3 units, right? 0, negative 3, 1 would be negative 2, another one would be negative 1, and then the last one is 3. So it's 3 units away. Okay. And I want you to treat absolute values just like parentheses. So if we have something like this, absolute value of, right, the absolute value of, if we have something like negative, absolute value of -4, what we do first is, well, what's the absolute value of -4? That is 4. But we still have this -1 on the outside, which means we have to multiply it, and that's just giving us -4. All right, so be very careful because a lot of the times we'll have something like this on an exam, and kids will just say, well, it's -4. Or not kids, students, my bad. Um, we also have something like this, right? And what I want you to do here is always do everything that's inside of the absolute value. Treat them like they're parentheses. So what is 1/2 minus 1? Well, that is -1/2, right? Since they're two different signs, we subtract them. 1 minus a half is a half, and keep the sign with the bigger number. Negative is bigger, so it's -1/2. This becomes just 1/2, or in fraction would just be, and that's our answer. All right. Similarly, if we were to kind of deal with um, this portion right here, this is the main one that kind of stumps people up, sorry, kind of causes an error, right? So do the thing inside, right? The absolute value first, so -8 is just 8, and then that negative sign comes down, and that is equal to -8. This will appear, most likely will appear on the exam. A question like this is more likely to appear to try to trick you, but hopefully you know how to do it, and we'll be good. Next thing I want to kind of go over that will most definitely appear on the exam is something like 6a, which is 8x minus 2 parentheses x plus 5 close parentheses is equal to -4 parentheses x minus 1 close parentheses plus 6. All right, and the first thing you want to do here is same thing, like I said. First, see if you could combine any like terms inside of the parentheses. Notice how here we have x plus 5 and x minus 1. We can't really do anything, but since it's separated by an operator, we could distribute and use distribution law. So let's distribute -2 in the inside and -4 as well. And so we get now 8x minus 2x minus 10, right? -2 times 5 is -10. On the other side, we have -4x. -4 times -1 is +4. And then we just bring down the 6. So far, so good. This is kind of helping us decide and figure out what's going on. Now we could kind of combine like terms. On this side, we have 8x minus 2x. Well, 8x minus 2x is 6x. We bring down the minus 10. We can't combine this, so we're good. And on the other side, we can't combine -4x, but we can combine 4 and 6, and that is 10. So we have plus 10 because of these two, right? And then -4x. Now, my whole goal was to move things around. What I'm going to do is move all my x's to one side and all my constants to the other. So I bring down my little borderline, and now this is what I'm going to do. I'm going to add 4x on both sides. So here it gets canceled, but on this side, whatever you do to one side, I must do to the other, right? But I'm also going to plus 10 on this side. Why? Because it cancels out, but I get to move all my constants on the other side. And what I get at the end of the day is now a new set. And that is 6x plus 4x is 10x. And on the other side, I have 10 plus 10, which is 20. And last but not least, right, what do I do here? Well, how do I get rid of 10 times x? The opposite, which is dividing by 10. Divide by 10 on both sides, and we get x is equal to 2. And boom. And what everybody should do, you're not going to get graded, or I won't take away points if you don't if you don't check your work. You do have to show your work. But if you check your work, it's not mandatory, but everyone should do it because it's very important. Now that we know that x is equal to 2, we could plug it into our equation. We could plug it into our equation, and that should help us. So let's remember our equation is, what is it? It's 8x minus 2 x plus 5 plus 6, right? That's how our equation looked like, right? Now that we know that x is equal to 2, we could kind of check our work. So let's do that. So in every single x that we see, we're going to plug in 2. Perfect. So let's do this. PEMDAS first, so parentheses first. What is 2 plus 5? That's 7. So we have 7, we have 2, right, is equal to, what's 2 minus 1? Well, that's 1, so it's negative 4, 6. Last but not least, what is 8 times 2? That is 16 minus, and then what is 2 times 7? 14. And that has to be equal to negative 4, because negative 4 times 1 is negative 4, plus 6, right? And now 16 minus 14 is 2. And on the other side, what is negative 4 plus 6? That is 2 as well. And we checked our work. We essentially went from solving our equation, right, solving for x, and then checking our work. And now you're 100% correct, because if they both match up, then nobody could tell you're wrong. And everybody should do this on the exam, because it will guarantee you that if you do it correctly and you get everything checks out well, then you 100% got that question right. There's no way you would get it wrong. Well, I will say, and I'm not the neatest person when it comes to writing as well, but everybody should kind of write or do their math very neatly, because unfortunately sometimes we do it quickly or we're not as neat as we should be, and then we get something wrong midway through the process and we think we got the answer, and when we plug it back in, it doesn't equal out. And then you're stuck there having to go back and trying to figure out where your mistake went. And that's something that costs you a lot of time and effort. So when you're doing your exam, please try to be as neat as possible. Try to show steps from step 1, step 2, step 3, step 4. So then you, in case and if for whatever reason there was a mistake, you can kind of work backwards and see, oh, this is where my mistake went. Let me start from there and kind of fix it. And you'll be able to work more efficiently and guarantee yourself a better outcome, right? So let's say, unfortunately, let's say I put -4 instead of +4x, then I could kind of see where I went wrong and then kind of fix it along the way. But everybody should do this. Everybody should check their work, especially when it comes to questions like this or questions that deal with um, inequalities. So let me get the eraser and let me go to the next part. This one, I can kind of say that it will be on the exam, or a question like this most likely looks like it's going to be in the exam. Is equal to 2x minus 1 over 4. And here we have to be very careful. We've worked with fractions before. Remember, with fractions, we gotta make sure that the denominators are the same. In order to add fractions, the denominator has to stay the same. So let's turn everything here into a fraction, which, to be honest, all we really have to do is just turn this one into a fraction. So that would be 2 over 1. Now it's a fraction. Now, in order to add fractions, of course, you have to make sure that their denominators are the same. And that means we have to see, when will 3, 1, and 4 be the same? And we could kind of work here and try to find the multiples. And so let's do 4, 1, and 3. Well, we have, oops, not that. Well, we have, right, we have 4, 8, 12, 16. We have 1, 2, 3, 4, dot, dot, dot. We have 3. We have 3, 6, 9, and 12. And notice that 12, 12, and if we continue with 1, right, we'll eventually see 12, is the least common denominator or the least common multiple, and that's what we have to do. We have to turn every single fraction here in terms of 12. So let's do that. 12 minus 12, 12. So what did we have to multiply to 3 to get 12? Well, I had to multiply by 4. right? But whatever I do to the bottom, I must do to the top. And that means I have to multiply by 4 on top. And what does this do? Well, we distribute, right? 4 times x is 4x. And then 4 times 4 is 16. Right? So far, so good. What did I have to multiply 1 to get to 12? Well, I had to multiply 12. And whatever I do to the bottom, I must do to the top. And what is 2 times -2? Or 12 times -2, and that is 24. All right. And then what do I have to do to multiply 4 to get to 12? Well, I had to multiply it by 3. And then whatever I do to the bottom, I must do to the top. And that means I'm going to multiply by 3. We distribute, and I get 6x minus 3. All right. And now we could kind of join it, right? When we add fractions, right, we keep the same denominator. So 12 is the denominator. And we just add or subtract the top. So we get 4x plus 16 minus 24. And that has to equal 12 over 6x minus 3. Right? So far, so good. We could kind of combine like terms in the numerator. And we get that 16 minus 24 is 8. So we get 4x minus 8 over 12 is equal to 6x minus 3 over 12. Now here is where hopefully it doesn't get confusing, but I don't want to work with fractions. Fractions are kind of weird. I don't want to work with it. So what I can do is kind of multiply the whole equation by 12. Because what's the opposite of dividing by 12? Well, multiplying by 12. And when I multiply, right, well, this cancels out, and this cancels out with that again. And at the end of the day, we will have the following. We will have the following. We will have, because it cancels out, it's going to equal to 4x minus 8 is equal to 6x minus 3. All right, so all here we really did was, since there's a dividing, or we're dividing by 12, if I multiply by 12 on both sides, it cancels out the whole denominator. And now I'm just left with the numerator, which is way easier to work with. And here, like I said, we have to kind of just move things around, and let's do so. Right? I'm going to move my 4x. So what's the opposite of plus 4x? Minus 4x. What's the opposite of plus 3? Or negative 3, sorry. It's plus 3. So this cancels out, and that cancels out. We just move it to the other side. And then we get what? The following is 6 minus 4 is 2x. And then what is negative 8 minus 3? That is negative 5. All right. And then to get, oops. And then to get 2x by itself, what's the opposite of multiplying by 2x? Well, dividing by 2x, or 2. Sorry, dividing by 2. And we're left with x is equal to negative 5 over 2. And that's our answer. To check our work, though, we would have to plug in x into the following equation, or our original equation, which should be right up here, our original equation. So overall, just for the first one, please look back at your range and domain. It's very important that you kind of remember the rules, or at least not the rules, but the signs, right? So remember that included, right? Included includes the brackets, and then not included, right, includes these, right? And then we denote it with a dark circle. We denote it by an open circle. Less than or equal to, greater than or equal to, less than or less than. Please remember that absolute values, you kind of treat them like parentheses. Okay, so yeah, absolute value of 4, then that's just equal to 4. We have to do an operation inside of them, like absolute value of -2 plus 1, right? -2 plus 1 is -1. but then we still have the absolute value, and then it becomes 1. Let's recall that even if there's a negative on the outside, like negative absolute value of -8, right? We do the absolute value first, like absolute value of 8 of -8, sorry, is 8, and then we have that negative sign still, so it becomes right? It becomes -8. -1 times 8 is -8. All right, and then in the next video, I'll try to kind of explain what happens in the other questions. So parallel and perpendicular is probably the biggest one that we kind of have to go over, and it will appear a lot on the exam, or majority of the time it will appear on the exam, and I'll just try to get that part out as soon as possible. So let me stop this one and send it.